Hi, my name is Anish. I worked with Derek and Pranav, and we made FlipFind. The problem is over 50 million tons of secondhand household goods go to waste every single year. And that's a massive problem because that's a ton of like wasted kind of goods that could have been going to people who needed it. A lot of wasted material and a lot of pollution into the environment. And the sad thing is many people would buy something off the secondhand market if they could find something that they wanted. And there are things they want. They just can't find them because it's difficult to find good things on the secondhand market sometimes. And so our goal is to kind of help people find the goods on the secondhand market so we can solve the problem on both sides. The first thing we did was we went to Facebook Marketplace and we web scraped a bunch of different listings using Selenium WebDriver. We collected over 700 different listings across the Urbana-Champaign area. Then we had to pre-process the data with Gemini. The listings are cluttered with objects, as you can see here, with a bunch of different objects in the entire scene. And so we had Gemini generate individual item identifiers, the object size, and the price of the object from the kind of detailed and like kind of cluttered overall listing. Then we wanted to reconstruct the listings image into 3D. And so we took a description of the object and images of the object and kind of made a mask of the object itself. So we got a mask of just in 2D what the object looked like. Then we used a 3D reconstruction model called SAM3 to reconstruct the entire cup, in this case, from either one or multiple different views into a GLB file. Specifically, we accomplished this by running several checkpoints on modal. We had four different containers, each with several A100s, and with all those kind of optimizations put together, we had to run four reconstructions per minute, which is pretty good for this kind of task because it's very computationally expensive. This is our application. First, we type in the category of what we want to have in our kind of scene. If I type silver, we'll find several different options for silver kind of things from the Facebook marketplace. And they kind of automatically go on and on. And as you can see, they're getting placed automatically in AR because we turned every single object from 2D into a 3D object. And then you can take the one you want and go to Facebook and actually go buy that item. Now you might be wondering, how are we able to find what kind of things a person might want based on just a description of what they might want? And so basically what we did was we took all the images from the listings and took a vertex image embedder and created multi-dimensional embeddings of each image and put them inside of an Actian vector database. Then we took our prompt of what the user wanted and made that also into an embedding and used that embedding to kind of query the vector database to find the image that was most similar to the kind of description that the person wanted to. And in this case, they found a kind of image that kind of suits what they wanted. However, embeddings are sometimes kind of finicky. So the last step after embeddings is a final selection by Gemini. We take the final contenders and have Gemini pick what the best actual objects would be that a person might want, and then show them to the final user during the kind of AR phase. We had a Flask backend, and the rendering was based on kind of predicting how a object has to behave. We used the gyrometer and magnetometer to get the kind of the yaw and the pitch of the phone, and that kind of gave us a sense of the angle of where our object would be in relative to us, allowing us to render a 3D object into a 2D space. Additionally, we had to have a depth generator to make a depth map of every single frame or every few frames because we needed the depth to kind of predict how the 3D object would look. Because the deeper something is away, the smaller it would be, and vice versa. So we had to have the depth of the kind of object in addition to our magnetometer and accelerometer data to figure out exactly what the object would look like in 3D when rendered properly. Thank you.